Hausmann. Perfetto. Benvenuti, welcome to this amazing event. I'm Alga from HR department from VEDRAI, and for us it's an honor to host this amazing event with a special guest, Mauro Pelucchi. But first, our colleague Cristina from the data department is going to introduce VEDRAI and our technology. So, Cristina, the floor is yours. Thanks.
Hello everyone, my name is Cristina, I'm a data scientist in VEDRAI, and I would like to make a brief introduction about VEDRAI, who we are and what we are doing. Okay. So VEDRAI is a startup, and VEDRAI Italia has almost 80 employees currently, and we are in continuous growing, and the group VEDRAI has more than 120 people. The aim of our project is to optimize time for making business decisions. We have developed different projects in different areas like marketing, sales, production, management. And with the use of artificial intelligence, we provide forecasts of the main KPIs in these areas. We have given names to our projects such as James, Becky, Frank, and Bob, which cover different areas in the companies. For example, James is virtual SEO, Becky is a virtual purchase manager, Frank is a virtual sales director, and Bob is virtual production manager. And talking about our projects, the first one which we produced was James. It's virtual SEO. This project helps to set companies' strategies, identify the goals, and make the strategy to achieve these goals. To do it, we work with more than 200 internal clients' data and 100 features of external data. The main difficulty in this project was to produce a good feature selection algorithm and then make some regression models and optimization models to achieve good results. Another project which is already in production is Becky. In this case, the main goal of the project is forecasting raw material pricing trends, such as copper, zinc, aluminum, or gas. To achieve better prediction and forecasting, we use a lot of social network data, the data from news and exchange commodities. We apply some different methods of natural language processing and sentiment analysis. The main difficulty of this project was identification of causal relationship, such as, for example, how COVID can influence the trend of the price. And on the top of all of this project is classification models to predict forecasts. Another project which is in development now is a sales director, which make forecasting of production in terms of quantity and price. And here we use a lot of social listening data and news and market data, apply some techniques of natural language processing, and to another section of this project are dynamic pricing models and sales forecasting models. Here is a recap of main technologies that we're using in our project. And if you are interested to know more about our company or about our products, or if you want to apply to one of our positions, you can keep in touch with me or with some of our colleagues, and we can talk in aperitivo about all of this. Thank you.
si è venuto qualche problema con schermo.
Ready the map now. Okay. Yeah.
Aspetta, forse se mettiamo tutto schermo.
Ok. Slideshow o full screen?
Slideshow.
Good.
Okay.
Questo è
Hey, welcome everybody. Thanks for being here. Thanks to... Sorry. Okay. I would stay in this position, your presentation. Thanks for being here. Thanks to Vedrai also for the possibility of having this moment together. It is the first time since the summer break. We met a few times before during the year, and we are happy to stay in touch again after the pandemic. So it is already the third event actually. So I'm going very quickly. Because I want to give you a generic presentation of our association, our meetup. There are also colleagues here, so after we can have a chat about also the meetup. So we are an independent group founded on February 2016. Here you can see the series of the growth, and the forecasted to go up. And so basically we started with Gianmario Spagagna, the founder, let's say, of the association in 2016. And nowadays, after 6 years, we have more than 2,000 people. So actually 2,000 virtual people that interact with each other and then also physically during these events. And we meet generally like once a month. And so there are plenty of opportunities to stay in touch. And it is a technical community, so today we are going to have a tech talk, and we try to stick with this idea of having a useful application, let me say, of machine learning, data science, so that we can learn something that can be also used in our everyday work or research. Okay, this is tough. Okay, we have to work a little bit on gender diversity. Maybe. I am Leonardo, there is Matteo here, and then there is also Claudio, Massi, and also the other people that contributes to the success of the organization process of the association. So each one of us has a specific role, but actually, since it is a free meetup, we would like also to say to you, you can of course join us for the occasions like this, and also for the organization of events in your company or in your spaces if you have an interesting talk to give. Okay, so since we are 6 years old, we have a little bit of history, and so we have a YouTube account in which we are live now, so we record every session, so you can find every session there. And we also have SlideShare, where you can find the slides after the presentation, the technical talk. We collect the slides and we put them there, so you can find all the contents there. And then there is also the Medium blog, in which we write articles about the topics that we had during the last talks. So basically, if you go to Medium, this is our account, datasets Milan, and you find everything about last meetups. And for instance, robustness metrics was the topics of alchemy presentation that they gave us, that the speaker gave to us just before the summer break. And we are also on Slack, so if you want to join our meetup also on Slack, just text us and we give you the link to get in touch also there. Okay, and these are the other QR code. Okay, this is the fourth, so maybe I will stop here. And we have LinkedIn and YouTube that we decided to be the best places to share our content. So basically, you can also use the hashtag Data Science Milan that we use to share our contents, and you find the channel there where you can see all the contents of the previous meetings. Okay, so since we are a meetup, of course, we would like to hear from you, from every one of us, also the organizers or the participants, to have a talk. So just get in touch and we will organize something fun in your organization, or in your company, or in your university. Okay, thank you very much, and I will leave the floor to the technical presentation for today.
One second, because I need to stop the one and launch my presentation, because I think it's my... Okay, I need to stay here. So yes. I am quite worried about the presentation because I need to stay here, and usually during my talk I go here and here. So if something's wrong, please stop me. And the second topic, because I'm quite worried, because I will speak about economy, and basically I'm not an economist. So if I don't know, here there is some economists, please stop me, and so I can go out. So thank you, first of all, for the invitation. Thank you to Cristina, thank you to Massi and Leonardo, thank you to I don't remember the name. Alba, okay, thank you for the invitation in this beautiful location. So today I will start from some words, some observation of Cristina about how to use the data to create a strategy. Of course, so when I will start my work, Victor, in the next slide. So because in my job, I work a lot with the public administration, a lot of administration, European organization. I will say something in few minutes, and a lot of time to create something, to project something. Usually, I don't use the term forecast because it's something very difficult to do. Usually, I use this word to project something in the future. Usually, they use the frequency of distribution, the frequency of volume of the frequency of something in something, and it's something good, of course. But in a lot of cases, you can arrive to some conclusion that are completely wrong. Okay. In my work, we observe the evolution of the work. So it's something complex. So what we do is try to capture what are the more requested skills in one area, in one location, in one specific occupation, to a specific role. And of course, if you think about your skill, I think in common you have Excel, right? Everyone in this room knows Excel very, very well, of course. But of course, if I use the frequency of the Excel, if I use the Excel distribution, I cannot say that Excel will grow a lot in the next year, okay? Because it's something that you need to know to stop, okay? So it's not a conclusion, it's not to create a strategy, okay? So today I will try to speak about economy. I will try. I hope that I don't run some wrong conclusion. And I will use some specific index, because from the economy we can learn a lot of good metrics, and we can apply these good metrics with traditional data, new data, big data, and also in new specific context. Of course, to apply these traditional metrics to a new context, you need to pay attention, because you need to have very quality data. I mean, always we need quality data, but if you apply some economic model, the quality needs to be very high. And of course, you need to know very well the context, because of course, in our case, you will run technical work, but I don't know, it's very difficult to take some conclusion. So I will go very fast to the technical presentation. Today we'll speak about the economic complexity theory. I don't know if complexity is good or not good. I will try to run this presentation very interactive, so I will also run to you some questions about the complexity. This theory of complexity is not new, it's something that is arriving to us since the 2009. So the first mention, and if you run some queries in Google Scholar, you will find that a lot of economists, statisticians, and so on try to measure the complexity of something during the last 50 years. So it's not something new. So I will try to explain you how to measure this complexity, why the complexity is bad or good, and how to use the complexity to drive some strategy. I will give you some examples practically, because we try to apply this type of matrix to my data, and I will explain about my data in the next slide. But of course, you can. I will give you some insight to apply this theory to your data, because I think is very easy to apply this theory to some public data. And also to data from a company, data from an organization, and so on. If you have any question, so I don't know if you have a session at the end. Okay. So at the end we can talk about the economic complexity and also something other, also offline during the we have something to eat. Perfect. So something about me. So I'm Mauro Pelucchi. I really know. So I work in a company, the name is Let's Ask. We are not competitor with RAI because basically we work in different contexts. So, and my team is very small because we work in a very particular context, but it's the level market intelligence. So we work a lot of public administrators, mainly in the last, so we are a spin-off of the University of Milano-Bicocca. Currently, we are part of this multinational company, which name is Lightcast. We are present in the US, UK, Italy, Singapore, New Zealand, India, and something other. We are not so much because basically the labor market intelligence is not a big market. Our main partners are something well known, I think, because mainly we designed, we implemented, and we maintained the system of the European Union that collects data about the labor market. And we try to use this data to make reaction, release insight, and so on. We will see something together in the next slide. So, complexity. I think we can stay on the slide for the next couple of hours, but we need to stay here only a few minutes. So, complexity, I think you have a bad idea about complexity, because if I open today the news, or I don't know, newspaper, if I watch the TV, usually complexity is not so good. I don't know, also your organization, if you have a meeting with your manager, usually you need to simplify. So complexity is not good or is good. It's a question for you, I don't know. Any suggestion? How many people in this room vote for complexity good or bad? Good? Bad. So I think it depends. Usually my colleagues use a lot of this sentence. It depends. It depends by what we know about complexity. So let me explain a little more about complexity. We have a practical example, because we are data scientists, data something, data engineers, head of data something, and so on. So if you are a data scientist and if you want to become the more important data scientist in the world, I don't know where I am to stay, in your opinion. In Milan, Rome, Venice, the same. It's the same or not? It's becoming the same because we are working remotely. Okay, Right, good. But of course, I think, my opinion, I don't know if I want to be a leader in fashion. It's not my job, as you can see. But I will go to a place where fashion is quite important. I don't know. A lot of that a lot of students are coming in Milan to study our way to design stuff, to run a lot of fashion stuff. Made in Italy is very important. On the other side, if I want to become a leader in robotics, I will go to the MIT area, basically. Why? Because I will find a lot of people important that knows a lot of stuff about robotics at the MIT, and can go and speak about this stuff with a lot of our subject, our industry, our technologies, and so on. I don't know if you agree or not agree. Yes, we have remote working, it is important, but basically, if you want to be a leader in a position, usually you go where you will find a lot of students, teachers, important people where you can learn about this stuff. So in this case, complexity is good, because of course the fashion in Milan is more complex than in Bergamo. So I'm from Bergamo, as you can see. Okay, the design in Milan is more complex than in some other part of the world. The robotics in the MIT is more complex than here, because if I want to be a leader, I will go to MIT to study robotics. So what we can do is to try to measure this complexity, not with sentences and words, but with numbers. Why? Because in the data that we can create from the web, that we can find in your company, that we can have in public organization, we have a lot of flows of employee, volume, price, and if we are able to use this data to measure the complexity, we'll find that some areas are more complex and some areas less complex. Of course, we need to be an expert on the context to understand why an area is more complex or less complex. But basically, we can arrive to a data strategy and not to only words. So this theory is not new. Pointer. So it's coming from Hidalgo and Hausmann in 2009. Hidalgo restarted to study the economic complexity and the product complexity in 2020 with a couple of publications. This is a screenshot of the publication of 2020 from Hidalgo about economic complexity, product complexity. And basically what we can do is try to use this theory. I will go into detail about the theory in the slide, to measure the product space, for example, the activity space of a country. This is the activity space of Italy, measured with the export data of 2019. I didn't take if you go to the Atlas of Complexity, you have the website, it's public, you will find a lot of these nice charts from Hidalgo and from Harvard about each single country, each single sector, each single volume, because you can use different type of data: export, import, price. I will show you that we are using the number of job posting in occupation for skills to measure the complexity in this case. As you can see, it's something tough. So mainly we are with data. As you can see, we have a lot of nodes, a lot of edge, some colors. It depends by the sector. You can see here the sector and the size. What is the size? Of course, we can use a frequency to measure the importance and the complexity. But if we use every time the frequency, we will arrive every time to some conclusions that are not real strategic, in my opinion. In my previous experience, I worked for a private company, and of course, my sales manager, my commercial director, knows very well the first 10 products that the company sold. I think also in your case, I think you know if you are working in a company, what are your best customer, what are the second customer, the third customer, usually. It's something not so important. Here in this case, we are using another type of measure. It's a measure of importance, but it's not about the volume or frequency. It's something less different, because in some cases, the relevance of a phenomenon, of an activity, of a skill, of an occupation can be the frequency. Okay? In some cases, not. I have a question for you, one basic question. I don't know if you know what it is. I don't have the last number, but usually it's always the same. What is the more requested occupation in Italy now, in your opinion? The more requested job roles. It's something easy. Suggestion? Think about your days, my days. When I work remotely, every couple of hours, I have 3. No, you don't have the experience at home. Amazon Deliveroo. Why? Because we are working remotely, we need a lot of stuff, we are using a lot of e-commerce. So the first occupation is not something related to the software. It's something related to the logistic, transportation, and so on. Okay? Of course, this type of work, this type of job, this type of economy requires a lot of data, a lot of application, a lot of technology stuff. In fact, the second occupation are the software developer or something related to the software development. Okay? But as you can see, it's not so difficult to know what is the first occupation in Italy. So if we think about our days, for me, it's quite easy. So, and let me to go ahead. Sorry. So we can use this data to try to understand how is it difficult to make a product. So in this case, we are showing this slide how many electronic exports we have from the different countries. The green area are Asia, blue area are Europe, red America, and so on. So as you can see, it's completely different. And I don't know if something so obvious. Of course, we know that a lot of electronic stuff are coming from China, Taiwan, Korea, Vietnam, but as you can see, the volume are very different. Okay, and in this case, the side of the chart is not only about the volume, but it's about the importance of the export. Okay, so as you can see, it's something completely different, at least in my mind. Okay, at least China was in the position, in my mind, US into the second position. As you can see, we have a lot of different stuff that we can start from the data. And this is very important for the company. Let me mention something. It's important for the company to help people know where is the complexity of the work. It's important for a company because, I don't know, if they want to start with a new brand, to know where is the knowledge to produce some stuff. It's important for the policy makers, for the decision maker to know, because I don't know, if I have to start with a policy, maybe I will learn something from this data, and so on. So, economic complexity is something related to two specific measures that we can start from the data. So, I will go more technical now. The diversity and the ubiquity of something. So, the diversity is expressed about how many activities are in an area. The ubiquity measures the specificity of these different activities. I will go to some number in this slide to give you some. So, why we measure economic complexity as the number of activities? Because you know, if you are in Milan we have a lot of different activities. And you can apply this new concept, for example, to your specific organization. So in Milan, we are famous for fashion, design, food, fintech, data. Okay. Of course, I can sum this phenomenon, but at the end, I don't know what I find. In other area of Italy, of another part of Italy, I will find something different. In Bergamo, we have famous for the building, for mechatronics, for some specific companies. If I go to the area of Veneto, I will find something different. Of course, in some cases, it's important to sum something. In other cases, it's better to observe the evolution of this different volume. For example, we apply the same concept from the Hidalgo theory to the labor market. How? Simply, we replace with it. So, the same theory, the same formula, the same libraries. We use the volume of jobs, the volume of employee that we have for an occupation, and the skill required to run this occupation. Data scientist skill could be Python, machine learning, artificial intelligence, so technical skill, so skill like management, team working, solving, the knowledge of some software, I don't know, and so on. So we replace the data, but basically we apply the same theory. And you can go ahead with a business exercise by applying your data. For example, for a company, I think it's quite important to understand how is spread the knowledge inside the company, for example. Another stuff, if you have data about sales of your company, you can use the same data to understand if the outcome of a product will grow or will decline. Okay, why is important? Because in a lot of cases, so I was also a consultant a lot of years ago, in a lot of cases, a lot of companies have one product that sell to a single customer or customer, but they don't know, basically because they watch only to the frequency. So it's important to understand how it is this type of index, in my opinion. The economic theory is based on these four main indexes: the specialization, the diversity, the ubiquity, and the diversity. So let me to speak about the specialization. It's something very easy. So it is the significant presence or absence of one skill in one occupation. Or you can apply the same sentences replacing skill and occupation. So it is the significant presence or absence of the product for an area, of an activity for a company, of, I don't know, we don't have other example. And we can use number to measure the specialization. When we measure the specialization, we can arrive to a matrix with product and customer, with occupation and skill, with country and activities, and so on. By this matrix, we can compute the average index, diversity, and ubiquity. So, if we have a lot of specialization for an occupation, for a country, for a customer, for a product, and go ahead, we will have a high diversity. If not, the diversity will go down. And we can observe this evolution during the time. For the ubiquity, is the opposite stuff. Is the number of occupations that require this skill. Is the number of customers that acquire a product. Is the number of countries that produce a product. Okay, so it's something on one side, on the other side. So if we mix these two concepts, we will arrive at the index of economy complexity, and the index of the product complexity. And of course, it's a graph application, so we can also measure the proximity between the different nodes. In my application, I will measure the proximity between occupation, I can measure the proximity between skill, I can measure the proximity between countries, I can measure the proximity between customers. Okay? Why? Because we have practical needs of this type of application. If I have the proximity of an occupation, I can create a bridge between occupation. You know that the next year, 2023, will be the year of skill in the European Union. So to create program to upskilling person, to the skilling person is important. So we can use this data-driven strategy to create program. If I can create a bridge between customer, I can try to create a sort of membership economy. I don't know if you know something about marketing, if you are from marketing, but it's something I think very new, last couple of years. So it's something that can help me to create a better strategy about marketing, and it is waiting for skill. If I can identify some proximity about skill, I can create a more quality program. I can apply this stuff to the university, and that the university to you. I can apply for the skill. I can apply if I find, if I'm a company, and if I will use my data about the production, for example, I can find similarity and proximity, I don't know, in a plant that can make the same product, and they can go ahead a lot of time. So there is an application of this theory with real data. So this is UK. You know, I don't know a lot about the location in UK because I'm not an expert. I know that there is London is quite real. As you can see, this is the evolution of the complexity of the economy in UK by using labor market data. So basically, job posting data, but that we scrape from the web. As you can see, we started in 2003 with a lot of data from London, and in 2019. So every time when I am using economy data, I don't use data from 2020 for some reason that I think you know. So up to 2019, as you can see, something different. Is quite easy to find London, you see. I know that there are two Manchester City, Manchester United, something here. I know that there is Cambridge. I know where is Cambridge because it is this green point in a bunch of dark. Okay, Cambridge in the UK is very famous about engineering. I know where is Edinburgh only because it is this green part in the middle of dark, and there is this grey area. Do you know?
Glasgow.
Aberdeen. Why Aberdeen? Because in Aberdeen it's not so complex, but basically they have a lot of companies about oil and gas. So as you can see, the complexity of Aberdeen is constant. Okay, so it's very easy to compute this type of matrix. This is, I cannot see. Okay, so this is the plot of this chart in with horizontal axis and vertical axis. So we can use also the GDP per capita to better understand. As you can see, of course, city of London is another word. The is logarithmic scale, if I remember well. Or I don't remember it. No, it is not logarithmic. It is normalized to the GDP per capita. As you can see, we have a lot of our city and then a bunch of local units in UK. So we have something very complex and something completely different. So it's another way to visualize this map. So I can go ahead about.
It seems that some complex move the city of London.
Yes. Yes. So speaking about dimension and matrix, how to compute the economic complexity? So basically, it's a graph application. During the time, because so you need to visualize this information and to compute this information during the time, and you can use different type of flows of knowledge, flows of occupation, flows of job, flows of financial resources, flows of goods, people, technology, what you want, basically. So let me just speak about the arrow. Is an export, okay? Because so the economic complexity is good to measure the growth of the complexity, but you cannot measure with the import of something. Import of goods, import of employment, import of financial resources. Why? Because I'm importing complexity. Okay, so it's always something that you need to measure with an export flows. So this, sorry for the resolution. This is how Hidalgo defines the complexity. So it's a function. This is the complexity of an area, and this is the complexity of a product. You can change the word and nothing will change. This is the complexity of a job, and this is the complexity of a skill. This is the complexity of a customer, and this is the complexity of the product that the customer acquires. And I can go ahead a lot of time. So specifically is a function where the parameters are the specialization matrix computed on the activity done in that area, computed by the skill required by the occupation, and the complexity of the product, the complexity of the skill, and so on. As you can see, it's something, if I remind the formula to compute the PCA, it's something not so different. Of course, it's something that you need to compute in iterative way. It's not something that you compute as is, but basically you can simplify the computation by putting some constraint. So let me to go ahead and to try to simplify the technical application. So I return to the case of Milan. How to normalize the stuff. So basically, if you are in Milan, we are famous for, I don't know, fashion, put a t-shirt, some dress, building, electronics. I cannot add the effect of the complexity and stop. Of course, so I can. I will run normalization extensive. Or in the other case, I can try to normalize every stuff. And I will indicate normalization intensive. What usually, so we can find a lot of different formula to compute the economic complexity in different way. It depends by the parameter that we can put under this formula. So we arrive to some conclusion about the labor market. It's something not fixed. It depends by the specific context. So, for example, in our case, we are computing the specialization of one occupation with the employment for the occupation and the number of unique postings that we have for that occupation in the area. So, as you can see, our specialization is computed with the XOS, that is the number of skill required to run the specific occupation, the number of job postings that we have in total about the specific skill, so not only about the specific occupation, and we normalize the data with the number of employees. So in this case, we are using two types of flows. The job posting, because basically we have a lot of job posting in our house, and the employment. And we can also recompute the same stuff. For example, in this case, we are computing the specialization in another way. Always we ponderate the data with the number of employment, because it's quite easy to find the number of employees in public site. In Italy, we have EUROSTAT, Spain, in Europe, we can download data from EUROSTAT, and so on. And here we have the number of job postings by the specific occupation for the specific area. So the same formula change flows. Of course, I need to start from the specialization. I will move to a binary specialization. What means? I will use the matrix computed with the specialization with some threshold. So in this case, we are using when the specialization is greater than 0.25, it will be specialized skill or the occupation, or if not, it's not specialized skill. So you can apply the same concept to country and activity, customer and product, plant and something other, and so on. Why this threshold? By the data. So in some cases you can use 1, in other cases you can use 0.5. It depends on the specific occupation. So usually what I suggest, start with the computation, observe the data, compute the index, try, and arrive to the index of diversity and ubiquity. what is the best on ambiguity? It's the sum of the number of skills that are specialized for the specific occupation. Or in the case of area and occupation, it is the number of occupation specialized in the specific area. This is the definition of diversity. The ambiguity, it is the opposite. It is the number of skills. It is the number of occupation that are specialized for a specific skill. It is the number of area where the occupation is specialized. So at the end, it's something very similar. So if you go in detail about the number, you will find some concept very similar to community detection, because basically, so if you iterate the formula, you will find that this theory, we will try to find a sort of network between occupation, between skills, between activities, and so on. And if you apply this theory to labor market data, you will find some very easy to use. So not frequency of skill, frequency of occupation. So, for example, here's the data that comes from UK. I'm observing the ubiquity of different skills. So as you can see, we have some skills that go down and go up. This is not the absolute value of ubiquity, but is the difference of the ubiquity measured in the different years. So as you can see, we have something in the 2020 stay fixed. We have some skills that where the ubiquity go up, agile methodology. What means? It means that in a lot of occupation, agile methodology is considered a specialization. I think all in this room know something about agile methodology, right? Scrum, agile methodology, something. Of course, we are not an expert, but we know something. If we know something, the ubiquity go up. And in the opposite, we have aerodynamics. I think in this room, I don't know, no one, or at least few people, know something about aerodynamics. Yes, we know something about Ferrari and so on, but basically stop. Okay, we cannot speak about aerodynamics or fluid dynamics or motors and so on. So we can use ambiguity to create this type of path. I repeat, this is not the absolute number, it is the different since 2016, if I remember well, so from 0 and so on. Of course, under the hood, what we have? It is the relative comparative advantage, RCA. I think, I hope, it's the first time, I don't know, but you see this concept. So it's something very easy to compute. So I take the formula from Simone, but it's something very easy because there are a lot of libraries that compute this index. So basically this index measures the importance of something with the relation to this something to the entire world. Let me speak about my work because I think it's quite easy also to understand for you. So one skill, Excel, is present in every occupation, but it not means that it's important in every occupation. On the opposite side, I don't know, aerodynamics is very important for a specific occupation and is not present in every occupation. So this index helps you to define this type of phenomenon. So you will find that aerodynamics will go very high for some specific occupation because it's present only on this specific occupation. And you will find that Excel will have a very low RCA, usually under 1. Why? Because it's present in everything, not only in every occupation. So RCA is a measure to measure the relevance, the specialization, the importance. So basically, it is the same formula that we can have here. In this slide is simplified. In this slide you have the complete definition, but basically you can apply this type of formula. It's the same. Okay. So Let me go ahead how we are using this type of index, and then we go to view, because we have 10 minutes, to some practical stuff. So we are using this type of index to understand better the evolution of the labor market. So we are applying the same theory of Hidalgo of 12 years ago, 13 years ago, to new data, basically. Why? Because we needed to know why Excel is so important, or how is the spread of the knowledge intensity of Excel between different occupations. We can use this index to measure the outcome of the student of university. We can use this index to know where robotics is more important and less important. So this is a plot from UK. We are using metrics that are coming from the economic complexity. These are also components of the economic complexity. We have FCA and we have the density. So how we can use this data? This part of the chart is 2017. This part of the chart is 2081. So we have different occupation and different city. I love Aberdeen, as you can see. Aberdeen is always present in my presentation. Why? Because, as you can see, we have the mechanical engineers that grow up. So remember the state of the economy now and the oil and gas. Okay. So as you can see, we have a place basically where all the companies are about oil and gas. Okay. So the mechanical engineers is something very technical. Sorry about the labor market. Of course, we are not using all the data as is, but we are applying some normalization. Mechanical engineers is part of the taxonomy called standard occupation classification, basically that have only 400 occupations that cover all the job titles of the world. Why? Because on the other side it's impossible to analyze the labor market. So under the mechanical engineer, we can find all the occupation about the mechanical engineering. I don't know, pipeline engineers, the expert about energy and so on. So as you can see, the complexity, the density, and the FTA of the occupation is growing in Aberdeen. So it's more important, more specialized. So if you are in Aberdeen and if you will take a master degree in mechanical engineering, but also bachelor degree, I think you will find a good work. And on the other side, if we see Birmingham, so I don't know nothing about the UK, but what I learned from my UK colleagues, City of London is something. At the second position and the first position, if we try to create a sort of ranking between local area UK, you will find Manchester and Birmingham, but are sort of competitors. So as you can see, we have this green square, that is Birmingham, electronic engineers, that is going down. So what do you mean? What I mean is the SDA of the electronic engineers in Birmingham is not so growing. It's going down from 2017 to 2021. It's a sort of projection that we can have about the labor market in the future. And you can apply the same concept with our data. So let me to go ahead about engineering and specialization. So as you can see in this slide, I'm putting the diversity during the time of a specific occupation. I am every time I'm using the difference between the year and the origin, 2016. And as you can see, I'm trying to measure the evolution of the diversity. What we can see, 2020, everything go down. Okay, I don't know. But then we have the restart with different velocity. Okay, we have the design engineers that grew a lot, we have the mechanical engineers that grew a lot, the technicians that grew a lot, and so on. So it's a matter to understand the what's happening. And of course, we can apply these techniques also to measure the complexity about the skill. So as you can see, so it is a basic started I showed before with different skill, but you can also compare the ubiquity of skill the ubiquity of a product, the ubiquity of activities, by comparing the absolute number. So as you can see, if I compare the ubiquity of a different skill, communication is always present, Excel is always present, and I can go down to the other skill. The component engineering is declining. Why? Because it's present in less occupation. I can go ahead. What is the evolution that you can apply? You have to mix the two stuff. If you apply the economic complexity and the LCA matrix, and also you observe the data not in a single line, but 3 lines together, you can understand also the intensity, for example, of the knowledge. I'm using available market data, but you can apply this stuff also to other data. So in this case, I am taking the relation between Excel and our skill in our data. You can use the same stuff with activities, products, and so on. So what you can try to understand is how many times is present Excel with SQL, and how many times Excel and SQL are present together with an high LCA. On the opposite, you can measure the presence of Excel with warehousing and measure how many times the two stuff together are specialized. What we found? We found that Excel and SQL, when are present together, the salary is going up. And we found that Excel, when it's present with warehousing, the salary is going down. What I mean is about intensity. It means that Excel is present in every occupation, in every type of work. We can run the same stuff about, I don't know, food, energy, in a lot of economic activities are present in a lot of countries. But of course, when Excel is present with SQL and we are programmers, scientists, and so on, the intensity is very high. In the same class of occupation, you can have what? Excel present with management. So basically, is when your manager is using, is a software developer, is using Excel to create account. Okay? So different knowledge, different intensity. Also for the elementary occupation, Excel is so important, but it's not so intensive. So I can go ahead with Python, with communication, and with a lot of different charts. So let me to show something from very practical, last 5 minutes. So, not this one. Sorry. What tools we are using and what techniques. So, okay. So, not this one. Okay. So, you will find a lot of nice library about complexity to compute this type of index. This is the official libraries. It's called EY complexity. It's from Harvard. Let me zoom a little. Okay. So you will find the code as public in GitHub, as you can see. And to apply it, you need only the data. Where you can apply the data? Of course, from your organization. Basically, you need one column, one category, another category, and one measure of price, volume, number of units, and so on. So 3 dimensions with a time. So usually we apply it with the year, because to capture this different month by month is not so easy. You need to measure to put the location, in this case location, but you can replace it with another type of category. It's not important to have location. You have the product, but you can have also another type. So in our application, we are using the year, the occupation, the skill, and the economic posting as a measure of the value. Or we are using this library with the year, the location, in this case it's the same, the occupation, and the number of posting. You can apply this type of measure with the year, the plant, the product, and the number of units made? I don't know. You can use also some financial application. I don't know. You can have the year, the customer, some index, product, something, and price. Okay? And I can go, I don't know. As you can see, it's not important to have a location and the product, but it is important that you have two types of categories to put this in relation, to have an index out of the volume. If the index go out from the node, it's better, because in our case, we measure the import of complexity and not the export of complexity. You can put some metrics to normalize the data. So, this is the parameter that you have. So you can use as test of specialization the RCA, like I mentioned, which is by default, or you can use another type of index. For example, in our application, we are using the employment number. You can use the population. You can use another index that you can measure to normalize the data and to understand the meaning. How to understand? You have to engage an expert of a context to read what you are seeing. To start, is just to use data that you have in this way. So I repeat, it's a normal pandas data frame in Python. I don't know if you're using Python. If you are using Stata or R, there is reporting of this library also in Stata and R, so the same. Basically, the parameters are the same. You need one measure about the time. I suggest you to use the year. So the format of the pandas data frame is a column with the year, a column with the category about the location. You can use a location, a product, an occupation, a customer, so on. Something about the product. In my case, I'm using the skill, but you can use something other, and something about the volume. So, if I go to my Jupyter notebook, of course, it's an interaction, so I will not calculate now because it will take a couple of hours with my laptop. So, as you can see, I have the data frame in this format. So, let me to zoom. So I have the occupation name, category, the skill name, another category. I have the year of reference, so like the previous example. I have all my index, for example, XOS, is the number of posting for this skill in this occupation for this year. So for this data set, I also have the number of employment in this location. For this example, I can use the number of employment in an occupation. I'm using this frame to ponderate the data. So to apply 3 lines of code, so it's very easy also on your side because you need to specify the name of the column of the year, the location, occupation name, the value. In this case is show because it is here. XOS, so number of skill by occupation by year. The same formula, as you can see here, I'm using a threshold 0.25, like mentioned in the slide. Usually, if I'm using some data from the export, I use 1, that is by default, usually by Hidalgo and also by the library. What you find is something like the 1. So, at the end, you will find a frame with all the dimensions. So, from the first part, the library will add the diversity, the ubiquity, the specialization matrix, the economic complexity index, the product complexity index, the density, and so on. Then you can use as you want this column. Usually, we moved to Tableau because for us it's more easy. Where is my Tableau? Sorry. It was on the other screen. So, for example, in this case, I computed the index Too little for me. Cannot zoom, sorry. Me to understand if there is a way to zoom, but no. So, 1 second, I will reshape a little the chart. With more good text. No. 1 second. So it is the frame in output from the library. In this case, I'm using data from EUROSTAT, so data that you can find publicly. The data are about the export of product for a country during the different year. In this case, they are using a standard CPA, is about to standardize the product. So, and in this case, I am trying to plot only the combination of countries and product where the SCA is greater than 1. So, to understand if there is something very specialized only in the specific country. So, as you can see, there are a lot of different products. I am using the first category, so something like 100 different categories about product with all the countries of Europe. The volume that I try to measure is the export of the product in Europe and also around the world. So, as you can see, something very interesting. I don't know what is this one, railway. Where is it? I don't find now. This one. Okay. So as you can see, if I watch, sorry for the dimension, but I cannot zoom. If I watch the column out the development of WAST and the country, I will find that in Europe only 2 countries are leading in this sector. That is Denmark and Sweden. So I think every country has something about the West. But if I watch the data, what I found that is not so spread around Europe. And I can go in detail to the single product. So pharmacy. I have Malta. I see Italy, as you know. I see Ireland. But as you can see, the specialization is different. In this case, more little, in some case, more big. And they can go ahead a lot of time. So, I think I'm around to the finish, and then I will leave it to you about the question. So, this is another way to plot the data about SCA and density. As you can see, in this case, I'm using a sort of mid-quadrant chart. I'm using the SCA on the vertical axis. I'm using the distance. So the density on the axis. I'm trying to split the space in 4 different areas. Why? Because here I will find the combination of occupational skill with SCA, important, relevant, and density. So in the future we grow. In this area, I will find occupational skill but are declining. Why? Because they are not so relevant with no outcome to grow. And in the other two part of the chart, we find something different. So, of course, so in this case, I'm using as line the 1, because to compute this data, I'm using 1 estimation about specialization, and to split about the density, I'm using the median in the data, but it's dependent on the data, basically. So, I don't know if you have any question.
policies that have been driven by some analysis of yours.
Yes. So about the labor market or the others? Labor market. Yes. So we are using this data. So it's something new because the theory of the economic complexity is quite old, 2019. But if you look in Google Scholar, in the Scopus, in our Scholar Big Data repository, you will find a lot of stuff about the measure of economic complexity. About the application labor market is quite new. We started RCA last year. I watched Simone. Economic complexity is completely new. We presented today in a conference a paper about this stuff in UK. Something real. So we are measuring, for example, the evolution of the AI. Why? Because AI is present everywhere, in every occupation, in everything, but it's quite difficult to understand how it is the evolution. So by using this measure, we can understand what are the locations with more presence of AI employee, AI student, AI staff, and also the companies, so private companies ask us to understand, okay, where I have to hire people, okay, where I have to start a new plan. In this case, we are using this method. So in this case, private company, not public policy. About public policy, if you look to Google, you will find a project with Arter. Arter is I'm trying to translate from Italian to English, is the labor market agency of Emilia-Romagna. They are very good because we are doing a lot of very innovative projects. A project that we are running with them is using this index and also other additional metrics to try to predict the crew of skill in a different cluster. For example, they have this concept of cluster where organization, public organization, university, and employers participate to speak about their work. So we are using this one to understand the evolution of the skill for the next couple of years. And they use the application basically mainly for the employers and for the ITS, so the technical institute in Italy. You know that with the Next Generation Fund, there is a lot of money spent to create a program to grow in this area, and we are using application to understand what are the more important skills in the labor market. So, two different steps. Another question? So, in this slide, because I think it's time. So, in this slide, I leave something also about, I have a last slide. So, no, it's important because this application, one policy, but is not so common in Europe, lucky, is about the collaborative learning. Why? Because if you apply this type of metrics to understand where you will find a lot of students, teachers, organizations, employers that are important in your specific context, you can apply this stuff to create a group of learning. So, I repeat, if I want to be a leader in the fashion, we will go basically Milan. If you want to be a leader in robotics, and if you apply the RCA, you will find the MIT and the Boston area is one of the leaders in this context. So you can apply this type of metrics to create this sort of collaborative learning, and also to try to predict what is the next data scientist occupation, what is the next data scientist, because data scientist is something very common now, okay? But what is the next? So because we have the genetic engineer, space theories guide, the robotics service technician, and so on. So I repeat, I use it in this case my data, but you can use a lot of different data to compute this index. Some suggestion to finish. So as you can see, it's very easy. also because the application, the library is ready. If you want to try to use this type of data, basically you can use data that are coming from the National Statistical Institute. If you go to the Institute website, I'm on YouTube, so I cannot say nothing. So you will find some data. EUROSTAT is quite good, have a lot of public data. You can start with public data, for example. Second, for example, this chart, I completed this chart this morning in 15 minutes, basically, with the library, with the data public available on the EUROSTAT website. So if you look for the export by country, by product, you will find the data you can download and create. I will share however the code and the dataset so you can reproduce. Okay. Of course, if you have data of your organization, I don't have unlucky data about plant and production because I think it's quite important. In my previous work, I needed to create a sort of benchmark about different plants, and I used standard data. But from this it can be a challenge. I don't know if you have, like me, in my previous work, 16 different plants that produce basically the same stuff. I don't know, it would be a good stuff to understand where the product is more complex, less complex, where there is relation, proximity between product, categories, and so on. So I'm lucky I don't have this type of data in my company, but if you have, it would be quite easy because I repeat, you need the year of production, the name of the plant, the category of the product, basically, and then you can arrive to a conclusion. I don't know. Okay. Other question? Time for drink?
Yeah.
Yes. If you have any question, fine. We can chat. Thank you.